Now, let's start with the part 2, the message format. Here is a real tool call. The exact message our client sent in the live session. Right, so when we ask what is 10 plus 20, right, so you can pause the video and you can read it to yourself, and then let's walk through it together line by line. The first line, we're going to code JSON-RPC : 0.0 2.0. This is just a version tag. It's always 2.0, 2.0. It confirms both sides speak the same grammar, same language. You will never change this value. The second line, ID : 1. This is the tracking number. Remember from the previous slide, when the response came, the response comes back, it must carry this exact same ID. That is how 10 parallel tool calls never get mixed up. The third line, method : right? So the method : the tool slash call. This is the action. Tools call me in, right? So run a tool for me and take a note of the other methods you will meet. Tools / list, show me the menu, the resources, read. Prompts / get, right? So, and these are, the different things that we are going to see, right? So, and we are going to initialize, which we will see on the very next slide. Now the parameters, the payload. Now, two things, right? So, now the two things are inside it. Name is add numbers, which tool it is, and add arguments. A is 10, B is 20, the inputs. Right, so here is the part most people miss. The server does not blindly trust these arguments. It validates them against the tool's input schema, and that schema was generated automatically by fast MCP, from your Python, or type hints. Right, so you wrote a :int, right? So B : int, that became the schema. Right, so if someone sends a string where an integer is expected, the call fails cleanly with an error. No crash, no garbage in your function. Now look at this response, same ID, that's 1, right? So the circle is closed now. And inside result, look carefully at the shape. The content is a list of blocks and each block has a type. Right, so here is one text block containing 30. Right, so here is where, that's going to contain 30. Right, so why a list? Because tools are not limited to text. A tool can return an image. It can return structured data. It can return several blocks at once. That is why content is a list. What if something fails? Right, so then instead of result, the response carries the error with a numeric code and a message. For example, right, so -32602. Right, so if I'm going to give some invalid parameters, either result or error. Right, so it's going to be either in result or an error, never both, never neither. Right, so one message shape, every tool, every server, that is the standardization we praised in one video, in the video one, right? So in the previous video. And now you have seen it with your own eyes, right? So now what happens if the tool itself crashes? Right, so if we are going to divide that by 0, what does it happen? The server catches it. Right, so the server catches it and returns an error object with the code and message. The client and the LLM can react gracefully. Remember, our divide tool in the live session raised a value error for exactly this. Right, so can a tool return an image or a file? Right, so this is a question, right? So an often asked question, can a tool return an image or a file? Yes, the content is a list of type blocks, text, image, or embedded resource. That's exactly why it's a list, not in plain string. Now, let's start with some of the interview questions here. Describe the MCP initialization. So if you can answer this one fluently, you are ahead of most of the candidates. So let's do it properly. So what is the very first conversation between a client and then server? Before any tool is listed, before anything is called, there is a handshake. Exactly 3 messages, always in this order. Message 1, initialize client to server request. The client speaks first. It sends an initialize request. Right? Note a request, so it has an ID and it expects a reply. So 3 things travel inside it. First, the protocol version the client speaks. Right? So the protocol version the client speaks. For example, right? So 25/7/2027. Right? So 2027 hyphen the month, July and 25. So this is the current revision of the MCP specification. Right? So the protocol version the client speaks. Right? So second, the client's capabilities. The optional features it supports are routes, sampling, elicitation. Right? So we'll unpack these on the next slide. Third, we have the client info, just a name and then version string. Now think of it as introducing yourself. Hi, I'm an example client. Right? So version 1.2. Right? So and the message 2, the response, client to server. I'm sorry, this is server to client. I'm sorry. The first one, what we did was client to server. That's the request. Now this is a response. When it's a response, it's server that is responding to the client. The server replies same ID. So we know it that it answers that request. First, the version negotiation. Right, so first is the version negotiation. If the server supports the requested version, it responds with the same version. If not, it proposes the latest version it does support. Right, and if the client cannot accept that, you take a note. The client simply disconnects. No guessing. No half compatible sessions. Second, the server declares its capabilities. I offer tools. I offer resources. I offer prompts. I can send log messages. Third, server info. Right? I'm weather server. Right? So and I have I'm weather server of version 1.0. Right? So this capability exchange is the heart of the handshake. This is the heart of the handshake. Both sides now know exactly what the other can do. Nothing is assumed. We are not assuming anything. Message 3, notifications and initialization. That is client to server. And here is the elegant part. The client sends notifications initialized. Right? So and we are going to look at the type. If right, so it is a notification. So what is the point that we spoke about notification? If it is a notification, there is no ID. There is no reply expected. It is just fire and forget. So it means one thing. Great, I am ready. Right, so from this exact moment, normal operation begins. Tools, list, right? So and tools call everything. No tool traffic before the handshake that's completed. That's the version first. Right? So there's no tool traffic before the handshake completes. Right? So before the handshake that's complete, there's no tool call there's no tool calls that's going to happen. capabilities first and then work. Now that is why MCP connections are predictable. Both sides agree on the rules before playing the game. Right, so both the sides, they're going to agree before playing the game. Right, so the question that often they asked, sir, do we have to write this handshake code? No, you definitely don't have to write. That's where the SDK comes in. The SDK does it automatically the moment you connect, but you must able to explain it. That's what interviews test. Now the other as interview question, so what if the versions don't match at all? The server proposes its latest supported version. If the client can't accept it, the client disconnects. A failed handshake means no session by design. Right, so is the handshake repeated for every tool call? No. We don't have to repeat this handshake for each and every tool call. Once per connection or once per session. After initialized, all tool calls reuse that agreed session. Now let's zoom into the capabilities. This is where MCP becomes more than just tool calling. What a client declares. Right, so I can tell you which folders you are allowed to work within. That's the roots. And the sampling, this one surprises people, right? So the server can ask the client's LLM to generate text. Right, so the server can ask the client's LLM to generate text. The server doesn't need its own API key. It borrows the model through the client with the user in control. Right, so next is the elicitation. Right, so what is this elicitation? The server can ask the user a follow-up question mid of the task. Which branch should I use? Right, so how is going to ask? It's going to ask through the client's UI. Now what a server declares? The first is the tools. We know the tools. Next is the resources. Read-only data. The files, database views. Next is the prompts. These are reusable prompt templates. Next is the logging. Structured logs back to the client. Right, so the two subflags or the interview points. List changed. Right, so the list changed. I will notify you if my list of tools change at any time. A change at runtime. Right, so we have something called as a list changed. Right, so I'll notify you if my list of tools change at runtime. A server can add a tool while running. Right, so I can keep on adding tools. Right, so when running, the client finds out it immediately. Then I'm going to use the subscribe or the resources. Right, so you can watch this one resource and I'll tell you when it changes. Right, so you're going to watch this resource and right, so when it's going to change, I'm going to just inform you. Right, so nothing is assumed. We are not going to assume there are so many tools. Then we are not going to assume that these are the capabilities. Both sides use only what was negotiated. If a capability wasn't even declared in the handshake, it doesn't exist, for this session. Right, so if a capability wasn't declared in the handshake, it doesn't exist for this session. Right, so our resources just get endpoints enough. Right, so tools is equal to actions like post. Resources is equal to read only data like get. Right, so tools are like actions like post. Resources are the read only data like get. But both travel over the same JSON-RPC messages. That's the important point that you remember. Tools are actions just like the post method. Resources are the read only data like the get method. but both travel over what? The JSON-RPC messages, be it the post or the tools and the resources which I mentioned. Now, the next question which I could ask here is, with sampling, who pays for the tokens? Right, so obviously it's the client side. The client side, the server borrows the hosts, right? So the server borrows the hosts model and API key with the user in control. Right, so it's going to borrow the hosts model and API key with the users that's in control. The server needs no key of its own. Right, so the server needs no key of its own. Right, now JSON-RPC is what you say. Right, so JSON-RPC, the transport is how you send it. Same language, different pipes. The MCP specification defines exactly 2 standard transports. Not 3, not 5, 2 standard transports. What are those 2? STDIO, Streamable HTTP. What is STDIO? The client launches the server as a sub-process. Right, so the client launches the server as a sub-process, a child process on the same machine. And they talk through standard input and standard output. One JSON-RPC message per line. Right, so we spoke about they're going to talk through standard input and standard output. There's no port, there's no networking, nothing to configure. Right, so like talking to someone sitting right next to you. Next is Streamable HTTP. So the server runs as an independent process, Streamable HTTP, on a port with one endpoint. Typically, MCP. Every message from the client is an HTTP post to that endpoint. Right, so every message from the client is an HTTP post to that endpoint. Multiple clients, remote servers, production deployments. Like calling someone on the phone. Right, so you're going to call someone on the phone. Right, so the first STDIO, I've given an example, like you're talking to someone right next to you. Here, it's in Streamable HTTP. Right, so multiple clients, remote servers, production deployments. It's like someone you're going to call on the phone. Right, so clients should support STDIO whenever possible. The simplest, right, most reliable option for local tools. Simplest option. Right, now some of you are thinking, right, so in the live session, right, so anyway in the live session we are going to use SSE. Where is SSE in this list? That's what, if you have seen the previous sessions recordings and all, we have used SSE. I'll answer that in the forthcoming slide. Right, so in the next 2 slides I'll answer exactly that. Right, now the question here is, which transport does Claude desktop use? Many of you should have used Claude. Right, so which one does Claude desktop use? Right, so STDIO for local servers on your machine. Remote hosted connectors use Streamable HTTP. Right, so remote hosted connectors use Streamable HTTP. Now, is WebSocket an MCP transport? Right, is WebSocket an MCP transport? Right, not a standard one. The specification defines only STDIO and Streamable HTTP. Custom transports are allowed but rare. Right, so custom transports are allowed but rare. All right. Now STDIO up close. Now details here that interviewers and production bugs love. Right, so this is a fantastic slide. Now the client owns the sub-process. I mentioned that earlier as well. Client owns the sub-process. The client launches the MCP server as a sub-process. Always remember, the client is going to launch the MCP server as a sub process and owns that process. Right? So the client owns the sub process. Now it starts it and shuts it down gracefully. Right? So what is shutting it down gracefully? Close STDIN. Right? So close STDIN. Now SICL. The server never outlives its clients. Right? So one message per line. Right? So one complete JSON-RPC message per line. Right? So one complete JSON-RPC message per line. So a message must never contain an embedded new line. Right? So STD out is it's sacred. This detail will save you a debugging session, one complete debugging session of a day. Right? So STD out, STD OUT is sacred. Right? So we are going to keep that carefully. The protocol lives in STD OUT. If your tool function does a casual print just to debug something, right, that print lands in the middle of JSON-RPC string and the client fails to parse it, your server mysteriously breaks it. Right? So your server mysteriously breaks it. Right? So the rule, logs go to STDERR. Never it goes to STDOUT. Right? So it's very important. Logs always go to STDERR, never to STDOUT. The specification explicitly allows standard error STDERR for logging purpose. One client per server. One client per server processes. Each client spans its own private copy of the server. Right? So this is perfect for ID integrations and local tools. Cloud Desktop uses STDIO for local servers, not how you serve 100 users. Right? So when we want to serve 100 users, for that we are going to we'll go to HTTP. STDIO is fast, simple, local. Remember, print breaks everything. Right? So if I can't print, how will I debug my STDIO server? This is one fantastic question that always asked by the student. If I can't even use a print statement, right? So here I mentioned you should not use print. If I can't print, how will I debug my STDIO? We are going to use the logging module to STDERR. Right? So or write to a log file and test with MCP inspector. Right? So which we'll use in the next video. Now, why does the Cloud Desktop prefer STDIO for local servers? Right? So why doesn't Cloud Desktop we mentioned? Why does it prefer STDIO for local servers? Because it has zero configuration. There's no open ports. That's private per user. And the client fully controls the server's life cycle. Right? So that's why it's going to use it. Streamable HTTP. The three things here. Now, streamable HTTP. The production transport. Three things to understand. Thing one, there is one endpoint, typically /MCP. Right? So every JSON-RPC message from the client is a new HTTP post to that one specific endpoint. And the server has a choice when replying. For a quick tool, say add numbers. It returns a plain JSON response and we are done. But for slow tool, imagine a web crawl that takes 30 seconds. The server can upgrade the reply into an SSE stream. And server sent events and push progress updates before the final results. That is the streamable in the streamable HTTP. Right? So on second point, thing two, the server can talk back. The client may also open a GET connection to that same endpoint. And the server uses that channel to push notifications. For example, my tool list just changed. The third one, sessions. At initialized time, the server can issue a header called MCP session ID. Right, so MCP session ID. The client echoes that header on every subsequent request. That is how one server process, serves many clients at the same time and still keeps every conversation separate. Part 2 is the correction. Now, the correction I promised at the start of this video, right? So you are going to take a note of this, carefully, because it affects the code that we wrote in the previous in the live sessions and all, right? So the earlier version of MCP had a transport called as HTTP plus SSE, two separate endpoints, one for the SSE stream, one for post. That transport is now deprecated, right? So there's no that is not present right now. Now it is replaced by Streamable HTTP in March, right? So in last year March, that revision that they have mentioned it. So it has, that's replaced by Streamable HTTP, right? So in the previous live session, we ran our servers with transport equals to SSE, and it worked, right? So nothing was wrong with that, what we built. It worked, right? So it worked because the libraries, keep SSE backwards compatibility, and they will keep it working for the older clients. But for anything new that you build from today, the correct option is transport is equal to Streamable HTTP, right? So Streamable HTTP, right? And here is your interview answer, right? So which transport, right? So which transports does MCP support? STDIO and Streamable HTTP. That's it. SSE inside Streamable HTTP is just a streaming mechanism. It is not a separate transport anymore. Kindly make a note of it, right? So which transport does MCP support? STDIO and Streamable HTTP. That's it. SSE that's inside the Streamable HTTP is just a streaming mechanism. It is not a separate transport anymore, right? So the third part is right. So one more thing while we are here. So the specification says servers must validate the origin header and should bind to localhost when running locally, right? So localhost is what? 127.0.0.1, right? This protects you, from the DNS rebinding attacks, right? So let's keep it local, wherein malicious websites reaches your local server. We don't want to happen that attack, right? So we will come back to MCP security properly in later video. One endpoint, post everything, stream when needed, and from today say Streamable HTTP, not SSE, right? So the questions again, the previous session recordings, you can see our library accepted SSE only. Why? The older versions of Python SDK predate Streamable HTTP. Upgrade the MCP package and you get transport is equal to Streamable HTTP. Your SSE code still runs. It's just the legacy path. So is the SSE dead? No. SSE, the browser technology is alive and used inside Streamable HTTP for streaming. That's what, right? So they have not deprecated, and this is the library component that's deprecated. The concept is still there. The technology is still alive and it is used inside the Streamable HTTP for streaming. What's deprecated is the old two endpoint HTTP plus SSE transport, right? So it's just HTTP plus SSE transport, right? So for the course, it works as is. For your portfolio projects, switch to Streamable HTTP. It's a one-word change. We'll continue about stateless and stateful in the forthcoming session.